All right, with that, let's get started with today's material. We're not going to be learning really any new math today. We're going to basically just be going over a bunch of application type problems for stuff we covered last week, 2 weeks ago, whatever. So this first next section is on calculating areas of rectangles using these quadratic formulas. So you're given some rectangle, you're told its area is 40, you're told that its width is 3 more than its length. How do you find its length? How do you find the x? Now first off, how do we calculate area? Length plus width?
Length times width.
Length times width gives you area. So we're going to take its length, multiply it by its width, and that's going to give us its area. So its length times its width is going to be equal to its area. Multiply your x through, you get x squared plus 3x. Bring the 40 to the other side, minus 40 equals 0. Now it's a regular quadratic equation. You can always and forever use a quadratic formula, or you can quickly see if there's an easy way to factor this. So let's see if we can easily factor it. Looking for two numbers, multiplied together gives us minus 40, added together gives us 3. Come on. What does 40 factor into? 20 and 2, okay, that's not going to work. Oh my goodness. What is 40?
5 and 7.
So close. 5 and what? 5 and
Oh,
8.
sorry, 5.
And what's 8 minus 5? 3. So I'm going to use positive 8 and negative 5. And that's going to work. So it's going to be x minus 8, x plus 5. Again, we could have found those numbers just using the quadratic formula, but this one was an easy one to factor. So we need that equal to 0. When is this factor equal to 0?
X equals 8.
When x equals 8. When is this factor equal to 0?
X equals 8.
So our answers are x equals 8 or x equals negative 5. Now why do I know that this is a stupid answer? Because I can't have a rectangle whose height is negative 5. There's no such thing as a negative distance. I want you to build me a pen. I want it 20 feet by negative 10 feet. It doesn't make sense. So you can't have negative distances. So our answer is x equals 8. So this pen here has a height of 8 and a width of 11? Did we mess something up? What did we mess up? Because our answer should be positive 5.
Is it positive 40?
Oh, duh. I don't know why I wrote it this way. Our 8 is positive and our 5 is negative.
Oh.
Duh. Because they add up to be 3. Okay. So x equal to negative 8 is one answer, and x equal to positive 5 is the other answer. And obviously the answer is positive 5. Notice what I did to figure out my answer was wrong. I did a quick sanity check. What is 5 times 8? 40. So 5 works. When you plug in 8 for this, you quickly see you run into a problem. What's 8 times 11? 88, not 40. Okay. So that's our first problem. So that's in working through it. Let's try another problem. So we start out with some square with side lengths x. We know that when we make our square 6 units longer on each side, we made the area 16 times bigger. So we start out with some mysteriously sized square. I'm not going to tell you how big this square is. Here's what I tell you. I tell you if I extend each of its sides by 6 feet, I made the area of the square 16 times bigger. Question, what were the dimensions of my initial square? So it sounds like a tricky question, but once you got this picture, it's real easy. All I'm looking at is x plus 6 times x plus 6 is equal to 16x squared. Multiply it all out, move everything to one side, you've got a quadratic equation. So multiplying this side out, what do I get? I get x squared plus 12x plus 36 is equal to 16x squared. Let's put everything on this side so that my x squared term is positive. So subtracting x squared from both sides leaves me 15x squared. I subtract 12x from both sides, so over here we have minus 12x. And subtract 36 from both sides gives me minus 36 is equal to 0. Now we can try and factor if we can see some nice way to factor it. Or if we don't want to have to think about it, we can always and forever just go straight to the quadratic formula. So let's go straight to that. So I've got this, so what's my quadratic formula? X is equal to negative b, in this case 12, plus or minus the square root of b squared, which is 144, minus 4 times a times c, all over 30. All over 2a. 30, right? Follow that? Now, hopefully I'll put my calculator in here so we don't have to think too much about this. So notice a negative times a negative is going to give me a positive. So 4 times 15, that's going to be 60. Times 36, what is that? 2,160, I think. 4 times 15 times 36, 2,160, okay. And then add the 144 to that, plus 144 equals 2,304. Does it have a perfect square root, or are we gonna have to factor it? It has a perfect square root. It's exactly the square root of 48. So you can take my word for it that when you multiply all this out, we get a really big number whose square root is 48, so we're left with 12 plus or minus 48 all over 30. Now we're talking about a distance here, and so obviously we don't care about the negative case, because if I do 12 minus 48, I get a negative number. There's no such thing as this square and actually having negative dimensions. So I only care about the positive case here. So what's 12 plus 48? 60 divided by 30 is 2. So x equal 2 is our answer. And we can go ahead and check that really quick. Let's see, 2 times 2 gives me 4. So we're saying that our initial square here had an area of 4, right? Now, let's see, what's 2 plus 6? 8. So 8 times 8 gives me 64. Is 64 16 times more than 4? Yes, 4 times 16 gives me 64. So this square has 16 times as much area as this square. So our initial square had side lengths 2, or area 4. Make sense? Okay. Same concept there. Let's try an equation like this one. Where is my eraser? Can you take it? All right. So, reading through this example, the area of a rectangle is 168 centimeters squared. The perimeter of the same rectangle is 52 centimeters. What are the dimensions of the rectangle? So I've got some rectangle here. What do I know? I know the area of the rectangle is 168. So its length times its width is 168. So we're going to call its length x and its width y. So length times width I know is 168, or in other words, x times y is equal to 168. The other information I have is the perimeter is 52 centimeters. How do you get the perimeter of a rectangle? You're adding up all 4 sides. Now this side has length x. How long is this side? Length x, length y. And so when we add them all up, what do we get?
100.
Ys equals 52.
2x plus 2y equals 52. The perimeter is 52. The area is 168. We have 2 equations, 2 unknowns. Solve for one, plug into the other. Doesn't matter which way we do this. I'll take this and I'll solve for y. So from this equation, I get y is equal to what? What's y equal to? What's y equal to? How do I get y by itself?
Put x on 2x on the other side.
We're looking at the top equation here. How do I get y by itself?
Put x, subtract x.
Can't subtract x from both sides. All right. If I know that 2x is equal to 8, what does x equal? 4. You crazy geniuses, how did you come up with that?
You divided.
You what?
You divided 2.
You divided both sides by 2 to get the x by itself.
Oh, so you're dividing x.
Divide both sides by x to get the y by itself. So we get y is equal to 168 over x. Can we follow that? Just divide both sides by x. Okay, so now that I have my y, I substitute it in to our next equation. So I know that 2x plus 2y is equal to 52. Right?
Yes.
Now, this is going to be a quadratic equation. First thing I want to do is get the x out of the denominator. So I'm going to multiply everything by x to get the x by itself. So then we're left with 2x squared plus 2 times 168. We don't have the x in the denominator there anymore because we multiplied by x. Is equal to 52 times x. Multiplied every term by x. You follow that? Now I'm going to get everything on this side. 2x squared minus 52x plus, what's 2 times 168? Thank you. And everyone's here.
396.
Close. What's 16 times 2? What's 16 times 2? What's 16 times 2?
32.
32. So what's 20 times, or so what's 16 times, well, so 160 times 2 then is 320. What's 8 times 2?
Is it 336?
Yes, it is 336. Good. 336 is equal to 0. Okay, let's divide everything by 2, make our life a little bit easier. When I take this term and I divide it by 2, what am I left with? I take 2x squared and I divide it by 2. What am I left with? X squared. Yes. I take 52 and I divide by 2. What am I left with?
Crap.
Not 25, but there we go. 26. X plus. Now 336 divided by 2. What's that going to be? 168. Good. Since we multiplied by 2 to get that, then dividing by 2 gets us back where we started. Quick thinking there. All right. And now we can, if we see how to factor it, we can factor it, or we can use the quadratic formula. Should we see if it factors nicely? All right, we're looking for two numbers that go into 168 that add together to be negative 26. So it needs to be two negative numbers. Let's see, 168, what goes into it nicely? Let's take some guesses. 168 divided by 8 gives me 21. 21 and 8 would give me 29. Doesn't come out nice. 168, what else might go into it? 12 goes into it. 12 goes into it 14 times. And so 12 and 14 gives me 26. So this is going to be minus 12 and minus 14. Adds together to give me minus 26. Multiply together gives me 168. How did I come up with the 12 there and the 14 there? I'm just guessing. So that was some educated guessing that 12 would probably go into it. Okay. So now we got this. What values of x make this true?
X is equal to 12.
X equal to 12 or
X equal to 14.
x equal to 14. Either of those answers are going to work. Going back to our picture, why are either of those answers going to work? If x is 12, we're going to find out y is 14. And if x is 14, we're going to find out y is 12. All that's saying is, whichever one's the shorter is going to be 12, whichever one's the longer is going to be 14. Just because we, in our picture, we called the longer one y, doesn't mean our math knows that the longer one's y. You see? So it's either going to be x is 12 and y is equal to 14, or x is 14 and y equal 12. Now, I'm just telling you that that's what it's going to be, but you can plug that in to see. 12 times what gets us 168? 14. And when we plug in 14 for x, y has to be 12. So you could have quickly calculated that from this equation. Or from this equation if you wanted. Make sense? All right. All right, let's do one more of these. They call them framing problems, and then we'll be good with this section. So how does a framing problem work? So on this picture, we have 8-inch by 12-inch picture has a frame of uniform width around it. The area of the frame is equal to the area of the picture. What is the width of the frame? So we've got some picture here. Remember, pictures lie. But this right here is a photo, and then we have a frame going around the photo. Now, this area of the frame is the same big as the area of the picture. Again, the illustration's lying. Don't read too much into the illustration. But the area of this thing is as big as the area of this outer piece. That's what it's telling us. You with me? Now we know the area of this inner piece. What's the area of this inner piece? 96. It's just 8 times 12. So the area of this outer piece has to be also 96. And so the area of the whole square here then has to be what? 192. How to get that?
Because it has to be twice as big.
Yes. So the area of the whole thing is 192. We'll just put right there. That's the area of the whole thing. Okay. So I forgot what we were looking for. The area of the frame is equal to the area of the picture. What is the width of the frame? Okay, so we're looking for the width of the frame, how wide this piece is. So we know that this picture is 8 by 12. The frame adds width on both ends. If my picture is 8 inches wide, and I stick it on a frame that has a width of 4 inches, how wide is my whole picture? If the picture is 8 inches wide, and the frame is 4 inches wide, how wide is the whole picture? 24, because you have a frame on both sides of the picture. The picture is 8 inches, this side of the frame is 4 inches, then this side of the frame is 4 inches, and the width of the whole picture then is 8 inches. That makes sense? So if our frame has width x, if we're saying this distance right here, whatever this distance is, if we call that x, then this whole thing's width now is 8 plus 2x. The width of the picture plus the width of the frame. Twice. Because you have the frame on both sides of the picture. Similarly, the height is the same problem. If the picture has a height of 12, then the height of the picture with the frame is going to be 12 plus 2x. So our equation now is that the width times the height gives us a total area. So I know that 8 plus 2x times 12 plus 2x is equal to our total area, 192. With me? Okay, first thing I'm going to do is factor 2 out of both of these. So factor 2 out of this and factor 2 out of this is a total of factoring out 4. When I take 2 out of this, I'm left with 4 plus x. And when I take a 2 out of this, I'm left with 6 plus x. Equals 192. You with me? Yeah. Okay, now it's 192 divided by 4. Here's what I would think. What's 200 divided by 4? What's 200 divided by 4? 50. And this uses 2 more 4s than this does. So if this is 50 4s, then this is 48 4s. So dividing both sides by 4, we get 4 plus x times 6 plus x, x, is equal to 48. With me? Yeah. Okay. Now, just multiply it out and solve the equation. So 4 times 6, I'll do my x's first. X times x gives me x squared. We get 4 x's here, and we get 6 x's here and 4 x's here for a total of 10 x's. And then 4 times 6 is 24, and this is equal to 48. Now subtract 48 from both sides, and we get x squared plus 10x. If I subtract 48 from both sides, what am I left with over here? Minus 24, but yes, is equal to 0. Now, we can use quadratic formula, or we can see if we just know how to factor it.
It's just 6.
It's just 6 and 4. Negative 6 and negative 4? Doesn't quite work.
I do. Yeah.
One of them has to be positive, one of them has to be negative. The bigger one has to be positive.
I have to do 12 and
12 and 2, that's exactly right. 12 and minus 2, right?
yes.
Okay, so that works. 12 and negative 2 gives us 10. 12 times negative 2 gives us minus 24. Yay, it worked. Okay, so now, what are our solutions? It's x equals minus 12 or x equals 2. Is it possible that our frame has a width of minus 12?
No.
No, so our answer is 2. And so 2 should be our answer. And we can quickly come and validate that. We're saying that, let's see, if x is 2, then this width is 12. And if x is 2, then this height is 16, right? And now we say, what's 12 times 16?
112.
Well, 12 times 12 is
144.
144. And then 12 times 4 is
36.
48.
48.
Now add those together and what do you get? So that's how I do it in my head, but however you do it's how you do it. Anyways, it worked. Okay, so that's the first section. We won't do another one of those. All right, next one. Teamwork problems. So 2 problems where you and I are working together. Let's say that we're looking at some task, like cleaning this room. I can clean this room in 3 hours, you can clean it in 4 hours. Question, how fast can we clean it if we work together? She just thrown out a number. Thank goodness she said a smaller number, and she didn't say something like 7. If it takes me 3 hours and you 4 hours, it's definitely not going to take us 7 hours to do the room. Don't think that way, because that's going to be the biggest mistake that you make. Now, if it takes me 3 hours, then that means I do 1/3 of a room every hour. That's my rate. Plus your rate, you do 1/4 of a room every hour. So how much of a room are we doing every hour? What's a third plus a fourth?
12.
Huh?
12 sevenths.
So close. It can't be more than 1. It's 7/12.
7
So this is the same thing as 4/12 plus 3/12. Multiply this one top bound by 4, this one top bound by 3, and you get 7/12. So we can clean a room, or our rate is we are cleaning 7/12 of the room every hour.
Right.
You with me?
Yes.
If we're cleaning 7/12 of the room every hour, how many hours is it going to take for us to clean the room? 1 hour and some leftover minutes. How much exactly though?
3.
We want to know how long it takes us to get 1. If I'm doing 7/12, here's how much I do every hour. How many hours do I have to do it to get 1 job done?
5 more. I don't know.
It's 12/7 of an hour. 7's cross cancel, 12's cross cancel, and we get 1. So if you're doing 12/7 of the room every hour, it takes you 7/12 of an hour. If I'm doing 1/3 of the room every hour, it takes me 3/1 hours. If you're doing 1/4 of the room every hour, it takes you 4/1 hours. Make sense? Now the general formula the author tries to give you to memorize this is, when it's a teamwork problem, you do 1 over how long it takes one person, plus 1 over how long it takes the other person, equals 1 over the total time. 1 over the time it takes you is your rate. The way I think about this is your rate plus my rate equals the total rate. The way the author tells you to think about it is, just do 1 over your time plus 1 over your friend's time gives you 1 over the total time. Whichever way you want to remember. All right, let's try out some of these. So, we'll see what Adam's up to. So Adam can clean a room in 3 hours, or in other words, his rate is 1/3 of a room per hour. If his sister Maria helps, I don't know what her rate is, so it's going to be plus 1 over how long it takes her to accomplish the task. If her sister Maria helps, they can clean it in 2 2/5 hours. Why would he ever write like that? They can clean it in 12/5 hours. So they can clean it in 1 over 12/5 hours. So they're able to do one room every 12/5. I'm able to do one room every 3 hours. Maria's able to do one room every X hours, we don't know. And together we're able to do one room every 12/5 hours. The time it takes me, the time it takes Maria, the time it takes us together. Or my room over my time plus Maria's room over her time plus the total room over the total time. However you want to think about it. Here's my rate, here's Maria's rate, here's our total rate. The setup to these is always going to be the hard part. Once you got that set up, now we can just start working with it the way we know and love. So first off, 1 over 12/5, that's the same thing as just reciprocal, 5/12. Right?
Yeah.
So I've got 1/3 plus 1 over x is equal to 5/12. I don't want the denominator there. I want to get rid of the denominator. So I need to multiply by the greatest or the least common multiple of all these numbers. In this case, it's 12x. So I'm going to multiply everything by 12x. When I multiply this by 12x, I'm left with 4x. No, because the 12 goes in the numerator. 12 cancels out with 3, leaving 4, and then x. Plus, when I multiply this by 12x in the top, x's cancel out, leaving me with 12. When I multiply this by 12x in the top, 12's cancel out, leaving me with 5x. Now, we simply solve for x here. So, move the x over here. We're going to subtract 4x's from both sides, and 12 is equal to x. Or, I can't remember what they were asking, Maria would take 12 hours to do the job alone.
Why does it take us so long to clean the room?
Maria, she's a slow worker. We don't tease her about it. All right. Let's try another one. That's kind of the same idea. This looks like a slightly more convoluted one. All right. For this next one, Britney can build a large shed in 10 days. 10 days less than Cosmo can. If they build it together, it would take them 12 days. How long would it take each of them working alone? Okay, so we're going to use x for Cosmo's rate. And Britney is Cosmo's rate minus 10. And when they do it together, it takes them 12 days. How long it takes Britney, how long it takes Cosmo, how long it takes them to do it together. Britney's rate per day plus Cosmo's rate per day equals the total rate per day, which is, they're doing this 1/12 of the project each day. So you can think about rate plus rate equals rate, or you can think about 1 over first time plus 1 over second time equals 1 over total time. However it helps you think about it. Anyways, now that we got this, we just need to multiply everything by their least common multiple. Their least common multiple in this case is going to be all the numbers. It's going to be 12 times x minus 10 times x. So I'm going to multiply everything by that. So when I multiply this by that, the x minus 10 cancels out, and I'm left with 12x for this one. When I multiply this by that, the x's cancel out, I'm left with 12 times x minus 10. So 12 times x minus 10. And when I multiply this by that, the 12's cancel out, and I'm left with x minus 10 times x. You with me? Okay. Now, multiply everything out, and then we'll collect like terms. So here we have 12x plus 12x minus 120 is equal to x squared minus 10x. Now I'm going to put everything on this side of the equation and set it equal to 0. So I'm going to have x squared. We have minus 10x, but I also need a minus 12x and minus 12x. So we're going to have a total of minus 34x, right? And then minus 120 from both sides, so we get plus 120 on this side is equal to 0. Did I do all that right? Minus 12, and plus 120. I think I did that right. Good? Now we can see if we can easily factor it. If not, we can always fall back on just a quadratic equation. So we're looking for two numbers, multiply together are 120, add together are negative 34. So two negative numbers. What goes into 120?
12 and 20.
So 12 and 10, right? 12 and 10, but when we add those together, not quite. Let's see, we could also do 40 and 3, but adding those together gives me 43, not 34. Let's see, if we did 20 and 6,
Why don't you do 30 and 4?
there you go, very common sense. Minus 30 minus 4. Good answer. Okay, so what is our x equal to? X is equal to 30, or x is equal to 4. Which of those answers are going to be the right answer? No, there's going to be one right answer for this. Which of those answers do I know for sure is wrong? 4. How do I know?
Because this is 10 days and 12 days to do it together.
It's 10 days
Makes less.
What's 4 minus 10? Negative 6. It can't take Britney negative 6 days to get the job done. It's got to take her a positive number of days. So x is 30. So working by himself, it would take Cosmo 30 days, and it would take Britney 20 days. Working together, they get done in 12 days. Follow that? All right. When someone's working against you, it's a minus. Let's just do one example with the minus. Okay. We'll just pause the lecture, I guess. Alright. Now let's get back to it. Okay. So for this next problem, it's going to be a problem where someone is working to get the job done and someone's working against the job being done. So here's the example. A sink can be filled by a pipe in 5 minutes. So my rate is I can fill one sink every 5 minutes. But it takes 7 minutes to drain a full sink. So if we unstop the drain, we are subtracting one sink every 7 minutes. Question: how long does it take to fill the sink? Because I got the sink filling up faster than it's draining. So I've got the sink on full blast, but I've also got the drain running. How long does it take to fill the sink? The hard part is coming up with a way to set up this problem. From there, it's pretty easy. So once you got it set up like this, multiply by the least common multiple of the denominator. In this case, that's going to be 5 times 7 times x, or 5 times 7 times x, 35x, multiply everything by 35x. So we'll get 7x minus 5x is equal to 35. 7x minus 5x is 2x is equal to 35 divided by 2. X is equal to 35 halves. So 35 halves of a minute is how long it will take to fill up the sink. Or he'll probably say 17 and a half minutes. 17.5 minutes. Okay, moving on to the next section. Next section, solving simultaneous products. We've already seen this in some of the examples. What's going to happen? You're going to be given two equations. Use one equation to solve for one variable, plug into the other equation. Same thing we've already been doing. So I know x times y equals 48, and I know x plus 3 times y minus 2 equals 54. Pick this, solve for x or y, plug it in down there. So if x times y equals 48, what does y equal? If x times y equals 48, what does y equal? What do I have to do to get y by itself? Divide both sides by x. Yes. So y equals 48 over x. Yay. Now, we use this to solve for y, substitute it in down here. So I know that x plus 3 times y minus 2 is equal to 54. Now, multiply it all out and go from there. So x times 48 over x just gives me the 48 because the x's cancel out. X times negative 2 gives me minus 2x. 3 times 48 over x is equal to, what's 48 times 3? 144. So plus 144 over x. So that's multiplying 3 by that. And then 3 times negative 2 is minus 6 is equal to 54. Good? Now I don't like the x in the denominator, so I'm going to just multiply everything by x. So we're going to get 48x minus 2x squared plus 144 minus 6x is equal to 54. Combine like terms, moving everything, let's move everything to this side so that our x squared term is positive. So moving this to the other side is going to give me 2x squared. Let's see, how many x's do I have? 48 minus 6 is 42. But when I move it to the other side, that's going to be negative 42. And then my constants, 54, now I'm going to subtract 144 from 54, leaving me minus 90, equal to 0. Good. Quickly divide everything by 2, and we get x squared minus 21 minus 45 is equal to 0. Now, let's see if we can think of a way to factor it, otherwise we use a quadratic equation. So we're looking for two numbers, multiplying together to be negative 45, added together is going to be negative 21. So they have to be a positive and negative. Our bigger number needs to be negative. Let's see. I don't think that's going to work.
Yeah, because there's nothing even that can add it.
So this one, probably just going to have to use the quadratic equation. So this was minus 21x, sorry. 21x minus 45. Let's just quickly scan down to make sure we didn't make a mistake in the numbers. We did make a mistake in the numbers. So, let's see. Minus 2x squared.
Positive 42.
Oh, I didn't multiply this by x when I multiplied everything by x. So when I was multiplying everything by x, I didn't multiply my 54 by x. No, that's why I did it wrong. Okay, let's try that again. This time we'll keep everything on this side just so that we can make sure we get the same number. So negative 2x squared is still negative 2x squared. Let's look at our x's. Here we have 48x. Minus 6x is going to be 42 minus 54x. Maybe an easier way to think about that is these two together will be negative 60, plus 48 will be minus 12. Right? Still not getting the same number. 48x. Oh, he kept the 54 over there. That's why. Okay, so forget what he's doing, just do what we're doing. Okay, so bringing this over makes this a minus 60, add to that is minus 12x. Okay. And then finally, we still have plus 144 equals 0. Good? Divide everything by negative 2, and we get x squared plus 6x minus, what's half of 144?
Oh, my God. Sorry.
That gotta be 12.
Come on. This is 12 times 12, so it's 12 times 6.
72.
72. Okay, and now we can factor it. X, two numbers, multiply together, give us that, add together, give us that. One has to be positive, one has to be negative. 12 and 6. Plus 12, minus 6. So my values for x are x equals minus 12, and x equals 6. I can't remember the context of our problem. So I don't know if there's a reason that we need to remove one of those answers. So I think they're both valid. So x equals minus 12 or x equals 6. Sorry, we didn't find the y's in each case. So let's find the y's. If x is equal to negative 12, what's y? Y is going to be equal to 48 over negative 12, which is equal to, what's 48 divided by 12? How many times does 12 go to 48? 4.
Sorry.
Add the negative 4.
Second
So,
is half.
if x is equal to negative 12, y is equal to negative 4. And if x is equal to 6, what's 48 divided by 6?
8.
8. And so negative 12, negative 4 are one answer, and 6, 8 are the other. So negative 12, negative 4, 6, 8. Okay. Next one. Some sort of money problems again. So let's see. A man buys several fish for $56. So he bought some number of fish, and he charged some price, P, we don't know, but we know in total he spent $56. Okay. After 3 fish die, he decides to sell the rest at a profit of $5. So he's going to take n minus 3 fish, since 3 died, and he's going to sell each of them for the price he paid plus 5 at a profit of $5. His total profit was equal to $4. So in other words, how much did he sell his fish for? 60, because his total profit was $4. He spent 56 bucks on the fish. He sold all the fish and ended up making $4. So he sold the fish for 60 bucks. Make sense?
Yeah.
So here's how the problem's set up. Once again, you see it's the exact same type of problem. 2 equations, 2 unknowns. We take one equation, solve for one of our variables, plug in to figure out the other variable. Make sense? So we'll work this one out. Let's see, n then is going to be 56 over p. Good. And now substitute in. So we got 56 over p minus 3 times p plus 5 is equal to 60. Multiply everything through by p to get rid of the p in the denominator. Well, first let's distribute this out, and then would it be easier to multiply through everything by p first? Let's multiply through everything by p first. Why not? So multiplying that by p, we get 56 minus 3p, all times p squared plus 5p is equal to 60p. Oh, no, that's multiplying by p twice, and I think that'll confuse you. Don't do it the way I did it. Never mind. Multiply it through first, and then we'll do the p. So 56 over p times p just gives me 56. 56 over p times 5 gives me, we'll just leave it as 56 times 5 for the time being, over p, whatever that is.
It's 280.
It's 280. Oh yeah, that's 280. Okay. Negative 3 times p is minus 3p. And then negative 3 times 5 is minus 15. Is equal to 60.
10 times.
Let's really quick move this and this together. 56 and minus 15 is
40.
56 minus 15 is 41. So we got 41 plus 2800 or 280 over p minus 3p equals 60. Multiply through everything by p. First, let's move this to the other side and multiply through everything by p at the same time. So 41 minus 60 is minus 19, right? P plus 280, no p since they cancel out, minus 3p squared equals 0. Move everything to the other side, and then let's see what we can see. So we got 3p squared plus 19p minus 280 is equal to 0.
Wait, listen. How's it gone negative
But I moved everything to this side. So that became positive, that became positive, that became negative.
Okay.
And now we'll just use the quadratic formula, the way we know and love. And so p is equal to negative b
Right.
plus or minus the square root of 19 squared minus 4 times a times c all over 2a. really quick figure out this number. So we got 4 times 3 times 280 equals that. We have 19 squared, that plus that, equals 648. Square root of 648 does not come out evenly. Which means, nope, he gets an ugly answer too. So since he gets an ugly answer too, we'll just have to find it, I guess. But I don't like that this is negative. $41. Let's see. Back to here. Make sure I'm not making a mistake. And let's make sure I got the same thing he's got. Oh, he substituted out the p's for the n's. So we'll get slightly different answers, but should be close to the same thing. 56p times p gave us 56. 56 over p times 5. 250 plus 30, 280, that's right, over p, k. Minus 3p minus 15 is equal to 60. Let's write our p first. So we have minus 3p. 56 minus 15 is 41, right? So that is going to be plus 41 plus 280 over p is equal to 60. Multiply through by p.
Did we do the same thing? We didn't add a p to the 16.
Now I'm going to multiply everything by p.
Right.
So I'm going to get negative 3p squared plus 41p plus 280 is equal to 60p. Subtract 60p from both sides, and I get negative 3p squared minus 19p plus 280 equals 0. Now multiply both sides by negative 1. That becomes positive, that becomes positive, that becomes negative. Okay, that's right. So then p is equal to negative 19, still getting that, plus or minus the square root of b squared, which is 19 squared, minus 4 times a times c. All over. Good. I think I'm still getting the exact same answer. So, 648. Let's see what we can pull out of that. What's a perfect square that would go into 648? We can pull out 3, which gives us 72. So this is equal to negative 19 plus or minus 3 times the square root of 72 all over 6. Let's see, 72 can definitely take a 4, right? 72 can also take a 9.
Right.
So let's see, 36 goes into it. There we go, that's what I was thinking. Yeah. So taking the 36 out, that pulls a 6 out here. So this is equal to negative 19 plus or minus, pulling a 6 out makes it 18 square roots of 2 all over 6. I don't know if we have any context for these where we can eliminate one number. Yes, we can, because it was for a price. So P is the price. You definitely didn't pay a negative number, so it has to be the plus here. Okay, so if that's the price he paid, now we can use that to figure out the number of fish he bought. And the number of fish he bought is going to be 56 divided by that. Let me see what he's getting for all of this. I'm getting such ugly numbers. Still have to have a mistake somewhere. I set the problem wrong? N minus 3, p plus 5 equals 60. N times p is equal to 56.
Why
P,
why they have a 60 over there?
huh?
Why do they have
What mistake do I keep making? I'm making a mistake twice. This can't be the answer because it needs to come out to a rational number. All right, let's plug in the n this time, or plug in the p this time. Shouldn't make a difference, but keep making a mistake I'm not seeing. So this time we'll say p is equal to 56 over n. And so this time, n minus 3 times 56 over n plus 5 is equal to 60. Multiplying that out, we get 56 minus 56 times 3 is 178. Did I do that right? Or is it 168? 168. I bet I keep making a small mistake like that in my head.
It's
56 times 3 is 168. No mistakes. All right, so minus 168 over n. So that's that, and that's that. Now that gives me plus 5n minus 15 is equal to 60. Okay, let's combine like terms. I'm going to take 56, I'm going to subtract 15, and then I'm going to subtract 60 and get negative 19. So negative 19 for our constant, minus 168 over n, plus 5n is equal to 0. I brought the 60 over. Multiply through everything by n. We get negative 19n minus 168 plus 5n squared equals 0. Rewrite it this way. 5n squared minus 19n minus 168 is equal to 0. Use the quadratic equation, n is equal to negative b, in this case 19, I like that better, plus or minus the square root of b squared minus 4 times a times c all over 2a. And I bet this radical comes out perfectly this time. So let's see. 4 times 5 times 168 plus 19 squared, and take the square root of that thing, and it comes out to exactly 61. So this is equal to 19 plus or minus 61 over 10. Obviously, we can't take the minus case because we have to, n has to be a positive number. So 19 plus 61 is 80 over 10 comes out 8. Okay, that came out clean. And then if n is 8, what's p? P is 56 over 8. So p is 7. So we paid $7 for each fish, and he bought 8 of them. Okay, that took way longer than it should have. So let's see, same type of problems. We'll do the second to last one in case it was hard. Or the last one. Nope, have to wait. Okay, so for this one, Greg went to a conference in a city 120 miles away. On the way back, due to road construction, he had to drive 10 miles per hour slower, which resulted in the return trip taking 2 hours longer. So let's see, his initial rate times his time was equal to 120 miles. Rate times time equals distance. That's him going there. On his way back, he went 10 miles per hour slower, so his rate on the way back was r minus 10. And his time on the way back was his time there plus 2. And that is equal to still 120 miles. Driving there, driving back. And so here's our two equations. We use one equation to solve for one number, substitute into the next equation. Just see which way the author went so we get the same number as him. He started out by solving for t. So we'll solve for t up here, substitute it in down there, and go on our way. So t is equal to 120 over r. We'll plug that in down here, see what we get. So we have r minus 10 times t plus 2 is equal to 120. Multiplying it all out, that times that gives me 120, that times that gives me plus 2r, that times that gives me minus 1200 over r, and that times that gives me minus 20 is equal to 120. Cancel out the 120s on both sides, and multiply through everything by r. So I get 2r squared, that's this term, minus 20r, that's this term, minus 1200, r squared when I multiply by r, is equal to that. Divide everything by 2, we get r squared minus 10r minus 600 is equal to 0. Let's see if we can easily see this. Two numbers that multiply to minus 600 but add to negative 10. Oh, 30 and 20. So this is going to be r minus 30, r plus 20 equals 0, right?
Yeah.
And so we get r is equal to 30 or r is equal to negative 20. Which of those answers is right? R equals 30. He doesn't have a negative speed. So his speed was 30 miles per hour and his time going there was 4 hours. So r is 30, t is 4. So 30 miles per hour was his rate. Maybe it didn't ask for his time. Okay. Let's do the last section here, which is graphing these quadratic equations. How do you graph these equations? You pretty much just plot points. Plug numbers into the equations to get a feel for what it looks like. So we're really quick going to scratch our table here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're just going to start plotting values. When x is 0, what's y? When x is 1, what's y? Etc. So plugging in 0 for this, what do we get? When you plug in 0 for x, what do you get for y? What's 0 squared? 0. What's 4 times 0? 0. So we're left with 3. So when you plug in 0 for x, you get 3 for y. When you plug in 1 for x, what's 1 squared? Minus 4 times 1, or minus 4 is negative 3 plus 3 is 0. Right? Now plug in 2. 2 squared is 4 minus 8. 4 minus 8 is negative 4 plus 3 is... Did we do that right? Let's try again. So plugging in 2. So this comes out 4 minus 8 plus 3. So it's negative 1, right? So when you plug in 2, you get negative 1. Now let's plug in 3. When you plug in 3, this is 9 minus 12 plus 3. Comes out 0. And when you plug in 4, it's going to be 3 again. So 4 squared is 16 minus 4 times 4 is 16 plus 3. Or in other words, 3. And so, when x was 0, our y was 1, 2, 3. When x was 1, our y was 0. When x was 2, our y was negative 1. When x was 3, our y was 0. When x was 4, our y was 3 again. And you can see the shape that this is making, and it's making this parabola. Not the best picture of it, but plot enough dots that you see what's going on, and there it is. So plot the points, da da da. We'll use the following method to find each of the points on our parabola to graph the equation y equals ax squared plus b equal to c. Find the following points. Y-intercept found by making x equal to 0. Okay, so common. Let's we'll let this go for today. We'll start with graphing next week. You got the applications ones. That's a good natural point. We'll start again with graphing next week. And then continue from there into chapter 10.